Once we load images into MATLAB, how can we perform common tasks like cropping or extracting colors? Well, we need to work with matrix representations of these images. Let's start by looking more closely at this grayscale image. A grayscale image is stored as a two-dimensional matrix of numbers, where each element represents a pixel intensity between 0 and 255. We can crop the image to contain only the man's face and camera by extracting a subset of the matrix. We extract the data by specifying the row and column indices of the data we want. Now, what about color images? Let's look at this example. Even though the picture is two-dimensional, a color image is stored as a three-dimensional array. This is because every pixel is made up of red, green, and blue intensities, also known as RGB values, which are used to define colors in digital images. Since the individual color components are represented by 2D matrices, we refer to them as color planes. This means an RGB image has 3 color planes. But often in image processing, we need to extract a single color plane or crop a color image. How can we do this? Here, the variable I stores the data. Because I has 3 dimensions, we must specify indices for each of them to access data in the image. To extract the red color plane, for example, first we use a colon to represent all the rows and all the columns. Then, as red is the first color plane in the third dimension, we use 1 for the third index. Notice that the result is a 2D matrix representing the red intensity values of the color image, and these values range from 0 to 255. Similarly, we obtain the green and blue intensity values by specifying the second and third color plane. If we instead want to crop our image to remove the background, we still need to specify the indices for all 3 dimensions. But this time we specify a vector of rows and a vector of columns for the first 2 dimensions, and we use a colon to select all 3 color planes from the third dimension. The result is another 3D array, but with fewer rows and columns than our original image data. So far, we've only extracted data from an image, but we can also modify the data. Let's see how. This cropped image appears to have mostly reds and greens. We can extract the color planes as before and display the resulting matrices. What do you expect to see once we display the intensities for each color plane? Well, the blue color plane image is much darker than the other 2. This implies that the blue intensities are lower than both red and green intensities. Let's see what happens if we remove the red colors. This command sets all the red intensity values to 0, and voila! Green is now our dominant color. Now it's your turn. Using the same procedure, you can edit the 3 color planes in the original image so all colors are enhanced. Great! This is how you work with image data. All of a sudden, I want a salad.